And since the logarithm, the base is e, and that's e. It's just 7.
Alright, here we go. Were there any odds that your group wasn't able to answer? You're still stuck on? 79. Okay. Anything else? 21's going twice sold? Okay, let's go ahead and go through our evens, alright? Color pens out. And get set up to look at number 79. Number 4, should have matched. Remember, the book always gives a little bit extra explanation, but should have matched C.
Yeah.
Number 6 should have matched B. Number 14 was a plug and chug into your calculator. You could have used either change of base formula. Now hold on, wait a minute. If you guys are cool and have these updated calculators where there's that log base feature, why on earth were they having you change the base to plug into your calculator?
In case you need it.
Yeah, number 1, what if your calculator doesn't have it? What if you need to use it to remind you to change your base? And then this book was made just a few years ago, maybe before the updates came out. Does that make sense? So anyway, in the olden days, a couple years ago, a few years ago, there was no log base button like the people with the yellow button right now on their calculator. So this was the only way to plug into your calculator. Anyway, just to give you a heads up. Number 16, you were starting to use properties. Let me give you a second on 16 and 20. The final answer is the very last line. That was their version of being fully simplified. You could have pulled out a 4 if you wanted to. That wouldn't have been bad. Ricky, go ahead.
For 20, it's good if you put negative. It's alright if you put negative.
I would put
plus
the negative
6.
2 in front. Yeah. So theirs isn't wrong, but I think it's confusing. So I would have preferred. I think it's actually more proper. Yeah. I would have liked that one better. So if anyone else did that, that's totally fine as well. You got it? Okay, let's keep going. Number 32, final answer is 3/4. Remember, ln of e is 1, not 0. A couple of you might be mixing that one up. Number 46, breaking it down. What's that snazzy word again? What were the directions for those to break it apart, pull it apart? Expand, good. So number 46, log of 4 plus 2 log of x plus log of y. And we can't put any of these together. We wanted them separated. The 2 came down because the x inside is simpler than the x squared. And we're trying to make the inside be as simple as possible. You were expanding in number 54 also, final expansion. Final expansion would be 4 log base 2 of x plus 1/2 log base 2 of y minus 3/2 log base 2 of z. Once again, I realize some of you are like, doesn't that look nicer though? But look at all of the mess in one logarithmic argument as opposed to just an x, just a y, just a z. This one, to be honest, is way simpler in many ways.
What if we wrote like log x? Wait here, I think I wrote log 2 of x plus log 2 of x plus log 2 of x.
You could have, yeah, it works.
More work
but,
for myself?
Yeah, more work for yourself. But in your thinking, just think those are technically like terms, so the 4 in front doesn't really complicate it, it more simplifies. But you were trying to break it down, and that's okay. I understand. Just a little more work than you. That is funny. Number 76. What's the direction when they're all spread apart and you're trying to see what the nice cohesive single log would be? Condense. Good. You're expanding and you're condensing. So real quick, log base 3, x cubed, y to the 4th over z to the 4th. Remember, the addition is multiplication. The subtraction means 1 division. There he is. Wait, was he the last one? Oh, that went fast. All right, and then you guys had a question on 79. So let me go ahead and get out of this. Let's get back to here. We'll just add a page because we did some homework questions yesterday. Yeah, Ricky?
When are we going to get the chapter 2 tests?
Chapter 2 tests? Those are the ones that you took on
Tuesday this week. No, Tuesday is last week.
This Tuesday, right?
No, last
Oh,
week.
it's Tuesday.
Because we
Yeah,
had,
that's not-
That was last time.
it was last Tuesday.
It
The
was
day
one of
before
the days that
the
was-
day before the PSAT.
We spent 3 days, anyway, long story short, they've been marked, I think they have to do partial credit and long answers. This is, if you wanna hear, is teacher recommendation season, and I have a lot of upperclassmen
Oh.
and a math department chair, there was an open house on Saturday. So long story short, there are a lot of deadlines before you guys listen. But they did get marked, and I have been showing a couple people this, what they got roughly after school, so I'll let you see. And there were a few people that needed to make it up, because they weren't getting it up. Okay, we are looking at number 79, because he was a little bit rough, yeah? There was a lot going on. The directions were to condense. And you had a 1/3 in front. Entirely in front. 2 ln of x plus 3. Plus ln of x, still in the bracket. Minus ln of x squared minus 1. All of it in the bracket. Ugh. Question, what's that bracket signifying?
Multiplying 1/3 by all of that.
Yeah, it's like one huge parenthesis holding in the entire thing. So question, if I have to, for condensing's sake, if I have to use the power property backwards first, or even kind of before, you can either start inside the parentheses first, then bring the 1/3, that's okay. Or you can bring the 1/3 in piece by piece and then make each of them a power. So it's up to you guys. What would you naturally think of first? Bring the 1/3 in, or like, hey, let's deal with the inside first and then deal with the 1/3.
Inside first.
That's kind of what I would think too, like PEMDAS, right? So inside first. Does anybody have any powers that we have to put in their rightful place?
2.
There we go. So what do you guys do with that 2?
Power.
Yeah, so the ln of
X plus 3
Quantity.
squared.
And then, oh, well, let me rewrite it. I was starting to do our plus and minus trick, but let's go ahead and take one more second to throw in our 1/3. Okay. We're dealing with the 1/3 later. Still going with the inside. ln. All right, cool. They're all ln. One single ln. Our 1/3's outside still. Okay, what happens when I write x plus 3 quantity squared and I read plus ln?
Multiply.
Good. Change it to multiplication. Take away the additional ln. Multiplication, eliminate the ln. And then when I read minus ln,
Division.
put a division, eliminate the ln. Got it. Now what do I do with that? Now, some of you might want to, and I kind of probably would too, write that x in front. Seems a little bit more proper. Because the x plus 3 quantity square is a little bit, the binomial square is a little more complicated in its notation. But what does that 1/3 mean? Yeah, just think if this looks a little too confusing with the brackets, think, hey, wait, I have this all condensed, so I can just say 1/3 times, right? The brackets just meant times. So if it helps, now we can technically just put the 1/3 in front and then say, oh, that's a 1/3 power, right? And as a few of your classmates said, a 1/3 power is the same thing as what kind of root?
Cube.
So you say ln of the big old huge cube root, x times x plus 3 quantity squared all over x squared minus 1. Done. Done. Caleb.
Okay, I once again did it a different, through like a
Okay.
more complicated way.
That's okay.
I did ln of x plus 3 and 2/3,
Okay.
and then I put everything else into a cube root. But it wasn't like one big cube root.
But
That's
technically, since you had the 2/3, so that was kind of, hold on, let me make sure I have down what you're saying. You could have written it like, I what you had?
No, I did, I did the equation separately, that's basically what I did, yeah.
So I was thinking that you had a cube root of all the rest, but you could have done like him to the 2/3, him to the 1/3, him to the 1/3. The only problem is that's kind of messy notation.
Yeah.
So when we do have them, I'm just going to write them totally separate for just a second. He would be to the 2/3. If you had brought the 1/3 in first, x would be to the 1/3, and then x squared minus 1 would be to the 1/3. You could have left the 1, left the 1, left the 2 or the squared, and made all of the thirds be a cube root.
Okay.
That would have been probably a way of processing that. Okay. 79. Done. All right, cool kids. Let's get back to section 3.4. We covered the one odd. Thank you for the groups that did collaborate. How many groups at least got the answer somehow? At least one question, at least one odd. We did one group. This group did. Okay, just 2 groups. All right. Just trying to gauge as to whether or not that can be helpful. You guys truly can be some of your best resources in the sense of helping each other. But if we're not really utilizing that time well, then you might just not use it. Section 3.4. Okay, do we like the one-to-one properties? Oh, yeah. But they only work when what? When we have the exact same logs and nothing else on either side of an equation, or when we have the exact same exponential functions and nothing else on either side of an equation. Struggle is going to be a little more complicated probably today, but we still like the one-to-one properties, so if we can use them, we will. Inverse properties, do we like that one? Because if we can get a to the power of log base a, guess what? Those cancel, x is x, there we go. Or similarly, log base a of a to the x. 2 ways of thinking about it. Log base a of a, in a sense, reduces, maybe I should be saying canceling. Reduces is kind of 1 times. If that's a little too complex, you can think of the power pops down. So x comes out in front, the log base a of a, that's all 1, x times 1 is x. Either way, they undo each other, right? Now, today it's not going to be quite that simple, but let's go ahead and start with a few simple ones and see if we know what to do. Let's start with a few, not simple, but maybe I should say more basic examples. All of these are equations, 1, 2, 3, 4, 5, 6. You've seen a few equations, but you haven't seen a lot, which is why this entire section is called solving equations. But these are simpler ones. So let's just go through them together real quick, okay? Letter A. What approach would you take? Take 32 and try to break them down? What happens when we break down 32? Is anybody using the box these days?
Oh, gosh,
Yeah,
no.
I did that.
You're just doing the tree?
The tree.
Either way.
No, the tree is wrong.
just hope that I'm right. Just because there's.
You can do like 2 cubed is 8 and then, I don't know, some of you just count it up. Either way though, what can we change 32 to be?
2 to.
Oh sweet, so x equals 5, right?
Listen.
Oh. We've seen ones like this. It looks a little tricky to begin with, but we actually don't have to undo the 2 because 32 can be put in terms of 2 to the power of, and it's not bad. Letter B. Okay, it's a little bit different than things that we've seen, but I think we can still do it. What do you think we should do? Get rid of the ln or rearrange stuff?
Rearrange.
Oh, yeah. What would we rearrange? Move it over by addition, yeah? Now we can say, oh, easy, the answer is x equals 2.
2, 3. 3?
I don't know. It happens. It happens. That was me all last class. I did 5 minus 1 is 5.
Same.
Happens, right? X equals 3, no big deal. Letter C, okay, not really anything to rearrange, but can we rewrite something? What do we see that 9 and 1/3 seem to have in common? I was just thinking they have 3 somehow involved in them.
Oh, yeah, I saw that too.
You were just getting a little too, hold on, you were going straight to the answer. So 3 is somehow involved. Question, David, what can we make 9? In terms of 3. Yeah. Now, might take a little more work over here on this side, but we've been doing this, right? 1/3. How are we going to put that in terms of 3? 3 to the -1, and you guys have gotten this down, right? 3 to the -1 to the x is going to be 3 to the negative x, right? Power to a power you multiply. Oh, so then negative x equals 2, so x equals -2. How many steps are these problems taking? 1, maybe 2, right? 1, maybe 2. This one kind of did too, right? Oh, you're over here on E?
Yeah.
Okay, now it's starting to get a little bit trickier, right? Can I make 7 a power of E?
No.
Try really hard. You could do like E to the 1, E to the 2, E to the 3. It's not 7, none of them. Oh well, that was E for effort. Anyway, chuckles and scoffing, either way I'll take it. Okay, so how do I get rid of E?
Multiply by
I can't divide by E. 'cause it doesn't
multiply by
have-
ln.
Yeah, can you just plot an
Multiply by-
LN on those?
Yeah.
Multiply by ln? Okay, you're close.
Oh, add. Just put the LN with close.
You can't. You're putting in an ln. You're writing an ln. Technically, you're taking ln of, right? So couldn't I do ln of e to the x and ln of 7? It will, yeah, exactly. That's why we did it. The same way that we can add something to another side, or we can, if we needed to, multiply something to 2 sides, divide. We can take ln of both sides, right? And why do we put it in ln? Because, Austin, you just said it. What happens with ln and e? Yeah, they reduce away, and all that's left is just the x. If you need to, you can think of the x comes in front, right? And ln of e, ooh, what? Log base e of e? Oh, just reduces away. It's really just a 1. So x times 1 is x, and on the other side, oh, hey, look, we're done. Dun, 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 dun. There was nothing really left to do. X was a 1.
Where's E?
E went away because ln of e.
No, the problem E. Straight to that.
Oh, I have no idea.
It's like the grading system, but no E.
A, B, C, D, F?
There was an E on the, okay, better read.
Depending on what E meant. Now wait a minute. We undid an E with who? ln. How are we going to undo a common log?
Yeah.
A big old 10. Yeah. Well, raising 10 to the power of, right? So 10 to the power of, remember? Common log has a little 10, so if I do a big old 10, it's going to cancel out. Do a big old 10 on one side. Ooh, what do I have to do to the other side?
Big old
Yeah.
ten.
Big old 10. What I'm doing is doing 10 to the power of one side and 10 to the power of the other. That thing you learned in algebra about what you do to one side, do to the other, it's way more broad than maybe you thought back then when it was like, ooh, I can plus to one side and plus to the other. Now we're going crazy like to the power of. But either way, on the left, if we have 10 to the power of log base 10, what do I have left?
X.
That's the inverse property, right? And then I have 10 to the -1. Well, that's an okay answer, but does anybody have a better way of writing that?
1 over 10.
Nice. My decimal people, I guess, you go to 0.1 if you really want to. How about the last one? Put a big ol'
3.
yeah. 3 to the power of the left and 3 to the power of the right. So 3 to the power of log base 3 of x, what do I have? Just x. And then 3 to the 4th. Mental mathers, you got that one? 81.
81. 80.
How? 3 squared and 3 squared, 9 and 9, right? 3 squared and 3 squared, 9 and 9. Now, each of these 6 examples, I'm going to go ahead and show you something on the next page that basically just talks through why we were able to do what we did. You don't have to write it down. I just want you to take a second. We've solved all 6 of them. I want you guys just to read for just a moment which properties went along with how we solved for them. Ready?
Whoa.
Okay. Here's each of our, oh hey, there's E. Why didn't I do him? A, B, C.
You did do it. You did it.
What did I not do? Oh, I think it's because I only wanted an even number of problems, and he would have messed me up. Oh well, that's okay. We used rewriting. Sometimes it was just changing a number to be his factored form. Sometimes it was rewriting by moving to the other side. Sometimes it was by changing how the exponents appeared for A, B, and C. And each of A, B, and C ended up using what property?
101.
That makes sense, right? We were able to go super fast. It's like, hey, they match, go. What was different with D, E, F, and G?
Inverse.
1-to-1 didn't work. We had to undo what was there to get to our answers, which would be undoing the inverse properties, right? So how did we undo E? Ln both sides. How did we undo ln? E to the power of both sides. How did we undo common log? You gotta remember that one. Log base 10. Good. 10 to the power of both sides. How did we undo log base 3? 3 to the power of both sides. All of those were inverse properties. Does that make sense? As far as properties. That was why it was legal. That's why it was okay. So what if it gets a little harder? What if it gets a little harder? Now the nice thing is, kiddos, for this entire section, today and tomorrow, this is basically the one page of notes. In the sense of, like, the one page of steps, the one page of, hey, let's summarize information and then get ready to go. And then the rest are examples. Today and tomorrow. So we're going to practice a lot, okay? And hopefully get a lot better at some of the ones that scared us last year. Or even scared us coming into the chapter at the beginning. You don't need to skip any lines until the undo step. Until the undo step. And then just skip a couple for each, okay? I'll give you a couple seconds to get set up. Okay. Thank you. So step number 1, when we have a more complicated, involved equation, somewhere in there we can see exponential, we can see logarithmic stuff going on. Maybe one, maybe the other, probably not both. We're going to use algebra. Good old-fashioned, nothing to do with the inverse property, one-to-one property, nothing to do with logarithmic or exponential anything. We're just going to say, hey, if we need to, if there's other stuff going on, we got to get it all away. We have to isolate. We have to use, there's something being added, subtracted, something being multiplied, divided. I need to get all the extra stuff away. So you need to figure out where's the exponential or logarithmic piece that's causing the trouble. It's going to have the x inside. And then say, what else is there? Okay, get over to the other side. Just get away, get away, get away. You want to get everything with x's on one side, everything without on the other, which I know that's something you've heard in algebra for a long time, right? Just as soon as exponential or logarithmic pieces come in, that flies out the window. So step number 1, get the pieces with the x's all together on one side. So everything else as much as you can on the other. If you can use the one-to-one property, sure, go ahead. He's easy. He's nice. We like him. You probably won't be able to very often. So then number 3, we undo. Now, kiddos, have we already, in those easy examples, I shouldn't say easy, they're not easy for all, but the simpler examples, did we undo some stuff? We undid him. We undid him. We undid him, right? But can undoing get any harder? Yes. So let's go ahead and zoom in on the undoing for a second, okay? How can it get harder? What if I was to give you something like, you ready? With logarithms. Should we do an example, okay? If you're going to use logarithms to undo. Actually, you know what? Let's say with logarithmic piece. I know. Trying to make it in a way that you'll remember most. Let's do with a logarithmic piece.
We can't do that with our notes.
I'm trying to write with pencil, don't you know? Because teachers change their notes.
It's true. And this is where you can change this a lot. True.
That's fair.
Okay. You see what I mean by with logarithmic, with exponential? You have logarithmic stuff, we gotta undo. And you have exponential stuff, you gotta undo. Now the undo, we're thinking once again inverse, right? We are thinking inverse, except maybe it's not as easy or simple, I keep saying that, simple as the ones that we started with. Like look at the first one. Guys, what's the problem?
Different log base.
Well, how are we supposed to do the idea if we have different log bases?
Multiply. Can you multiply by log base 3 and log base 2?
You check the back of the book.
We can't multiply. Wait.
Add.
We can't multiply to change a base.
Add.
We can't add to change a base. We have to.
Subtract. Divide.
Wait. What have I been saying? Change the base. Wasn't that a formula we've written down twice now? Oh. Wait. Change a base. If we don't like the one we've been given, we can change them to be whoever we want them to be. We just have to do it with a division. We just have to do it with a division. And we have to do a division of log base, the new base I want, of the argument over log base, the new base I want, same thing, of the old base. Those mean the exact same thing. Now it's up to you guys who you want to change them to be.
10.
We can make common log, we can make ln, or we can make the log 3 into log 2s, or the log 2s into log 3s. What do you want?
10.
Common log? Okay. So we're going to make him into a common log, so let's do log of x minus 1 over log of 2, log of x over log of 3. Question. Did I plug in the formula correctly?
Mm-hmm.
Hold on, I said here, else you don't know. Okay, I plugged in the formula correctly, so how do I solve?
Cross multiply.
Cross multiply, great idea.
Okay.
Otherwise known as undo the division, right? Undo the division. Long story short, we end up with log base 3.
What?
Doesn't he get multiplied by him? Times log of x minus 1 equals log of 2 times log of x. Wait a minute, but didn't step 1 say we want all the things with x's on one side? So if we want all the things with x's on one side, then question,
Divide by log base x.
well, how do we combine them though? Here's the struggle. Do we have a product property of different logs?
No.
Or a difference property? No. that doesn't work. But what we could do is maybe instead of arranging it this way, where now we have like numbers on one side, numbers on the other, x's on one side, x's on the other. What if we were to, you can keep it that way. You can make this the next step if you want. I'm just running out of room. You can keep it. What I'm going to do is keep the log of x minus 1 over here. And I'm going to move the log of x to be with, or to be over there.
You can do that.
And then I'm going to keep the log of 2 and the log of 3. Right? But at least the x's are on one side, right?
Yeah.
And then the numbers are on the other. So now how do we get x alone?
Cross multiply.
No, cross multiply is going to mix them all apart.
Subtract. You can make them subtract.
You could subtract that whole thing if you want. That's going to be kind of messy though.
Do it the Caleb way.
Division is inside the log.
Looking back at the book.
Ricky, I said that joke like 5 minutes ago.
It's okay. You thought it was applicable again, and it kind of is.
It is. Or just wait till tomorrow.
We could try to undo the logs with doing 10 to the power of both sides, right? Here's the struggle. Oh man, that one's rough. Now, we might come back to him tomorrow.
Calculator. Oh wait.
If worst comes to worst, there is a way to do it with your calculator. However, this is rough. Let's wait and let's see, okay? Let's look at another one that's a little bit harder that is going to be able to be solved a bit quicker. Okay? Long story short, some logarithmic problems might just be way out of our league. We tried. We were able to do some cool stuff with it. Maybe changing both of them to common logs got a little bit messier than we wanted to get. I probably would have just changed one of them to be the other. Might have made it a little bit easier, but we'll get back to that problem. Let's try this one though. He's a little bit easier. Why? He only has one piece, but we still have some work to do. Question, can I take log base 3 of both sides? Not yet. Who's messing up my 3 to the power of and I can't even really get to him yet?
2.
The 2. Okay, algebra. Not everything is as hard as this one. Algebra, how do I get rid of the 2? So if I divide by 2 on one side, and I divide by 2 on the other, now I have 3 to the power of 3x minus 1 equals 1/2. Okay, now what? Yeah. Which logarithm would you use for this one? You could do log base 3. Right? And what would you get over here? Remember, the power can pop down if you like that better. That all comes to 1. So we have 3x minus 1 equals log base 3 1/2. Now, I know you don't like what that looks like, but isn't this just a number we could plug into our calculator?
Yeah.
Okay, so he's just a number. How do I get x alone? Add 1. You're just doing algebra. You're just going to do algebra with these nasty numbers. Now be careful. I know it might be a little crazy, but those ones aren't like terms, right? He's a log, he's a 1. They have nothing in common. We're just going to write the 1 in front. Make sure you keep these things separate. We have the 3x over here. Now what are we going to do? Divide by 3. Now here's something crazy I need to show you before we finish for today. I want to try and get one more example that we get to a nice answer for.
Let's expand.
We could expand, right? Let me show you a couple more forms of this answer. Someone, instead of using log base 3, even though my 3 kind of got stuck in my little line, it's a little bit of a struggle. Instead of using a log base 3, they could have actually, I'm going to put a little or, they could have used ln's instead. So it would have been a little bit funny, but if they had used ln's, they would have gotten instead 1 plus ln of 1/2 over 3 ln 3.
What?
Guess what? Those are the exact same. Really? Hey,
Yeah.
it's a change of base formula. If they had used ln's instead, it would have worked also. They could have done what Ricky was saying, which was use the quotient property. And they could have gotten x is equal to 1 plus ln of 1 minus ln of 2 all over 3 ln of 3. And the crazy thing is, this wouldn't have even still been there because what's any log of 1 from yesterday, you guys remember? 0. So technically that would have gone away. Here's the struggle, guys. Don't these answers look really, really different?
Negative
So
sign.
how on earth, in homework, if there are different approaches to solving, how are you going to know if the answer you got actually matches with the back of the book? Because maybe you just did it a different way.
Calculator.
Yes. In your, listen closely, in your directions for all of section 3 and 4, or at least most of section 3 and 4 where you're solving equations, they have you basically solve for x, and then they tell you one extra direction. They tell you, get it to 3 decimal places. And technically, I guess, if we were to show it, we'd have to show little squigglies because 3 decimal places we're approximating, we're rounding. But what should happen if, as I said, all of these are the exact same? What's going to happen to their decimals?
Be alike.
They're going to match. So theoretically, you could do a problem and get to an answer in one form, get a decimal, check your decimal with the back of the book decimal, if it's an odd, or with the Calc Chat decimal, see if the decimals match. Maybe you just wrote it a different way. Does that make sense? Okay. So when they say a decimal, it doesn't mean like, whatever, let's just graph it and find the zeros and not even worry about the whole process. Oh, that's not going to work well in the test. But, they're having you find the decimals so you can actually make it match, in a sense, with another correct form of it that might just look a little differently than yours. Is that cool? Seeing why that direction is there? Okay, so tomorrow we're going to do a lot more examples, but for right now, let's just stay kind of basic. Let's stay kind of basic. One of these you've seen before, one of them you just saw one super similar to it. Question, kiddos, last 2 examples of today, how would you do letter A?
Raise it to
Oh.
ln.
You could, yeah. You could show the math. Careful with the raising, but you're taking ln of both sides. But technically, what property could we have just cheated and used real fast? 1 to 1. So it might show up in homework here or there. But then you just get negative x squared equals negative 3x minus 4. Hopefully a lot of you are with me and say, I don't want him to be negative. Let's move him to that side. Remember, if you have a quadratic, get one side equal to 0 and do your factoring. That's the only way to go. By those of you that are still struggling a bit with quadratics. But then we go ahead and solve x equals negative 1 or positive 4. Now, here's something a little tricky. When we're solving equations, every now and then extraneous solutions can come up. You're like, oh no. Extraneous meaning when we undo exponentials, when we undo logs, maybe some answers sneak in that technically are illegal. So one thing you can do is just plug them back in and say, hey, will this be imaginary? The nice thing is exponentials are never imaginary. Their domain is all real numbers, so they're fine. But logs, those get a little tricky sometimes. But don't worry, we'll cover more tomorrow. Real quick, how would you start this problem? You gotta isolate. That's going to be one of your guys' Achilles' heels until you get used to it. You got to isolate. Get the exponential alone. 3 goes into 42. Any mental math that's got it?
21.
14.
Oh, now what?
Now you do the log base.
Log base 2 is good, but can I just show you why ln works also? Because I've told you in calc, ln's way nicer. Why does ln work? That doesn't cancel. What happens to the x?
Goes in front.
And what can I do if the x is in front to get him alone? This is one way of writing the answer. His decimal would match with your log base 2 way.
I like that.
I like that way too. The elements are nicer, the buttons in the calculator, we're good to go. Bye guys, I'll see you tomorrow. Have a good rest of your Thursday, almost Friday, almost weekend.
Tyler, next week I have to stay at home. Tyler.
Let's see
Tyler.
Master.
Tyler, all next week I have to stay at home.
Okay, Caleb, why? Because you're in Troyer.
History of video games.
Same thing.